Hi grade 9s, welcome back to another one of our video lessons. So last lesson we ended off with looking at polygons and I showed you how to construct a quadrilateral with 30-degree angle. Alright guys, so remember with the polygons we did a formula that is quite important, so I will ask you that. So remember, if the polygon has n sides, then each angle at the center will be 360 degrees divided by n. Alright, so and these are regular polygons, meaning that all the angles are all the same within that shape. Okay, so let's just recap that. So let's say I have a pentagon that looks like that. So it's a five-sided shape. Might not look perfect on the drawing, but it's a regular pentagon, right? So what I can do is I can take a central point, connect it to each vertex like that, and that will give me these interior angles around the point, those 5 angles. Now those 5 angles, the formula is for those 5 angles, which says that they are equal to 360 divided by the number of sides, which is 5. So it's 360 divided by 5, which is 72, I think. All right, guys, so that's the formula. That's how you apply it. You can apply it to different polygons, okay? Right, so today we're going to continue on page 124 and we're going to look at geometry of 2D shapes. So from here onwards, we're not going to be drawing these things and constructing them unless I say in the test and exam that do this, construct this figure without the use of a protractor, show all your construction lines and so on. Okay, but for this section, we're going to use the geometry theory to answer the questions that we might have. Okay. So what I'm going to do in this lesson, I'm going to run through page 124 and 125, which is basically a revision or a recap of all our geometrical terms, what we've learned so far. And I'm going to look at exercise 13.1, which you guys are going to do for homework. Okay. Right, so let's start on page 124. So I'm going to read the maths ideas on the left-hand side. So guys, I don't know if you've noticed that, but at the beginning of each section or a chapter, there's this maths ideas on the side. So that tells you what are the main things we're going to be doing, or what are the main ideas that we're going to be facing. So properties and definitions of triangles, equilateral, isosceles, and scaling triangles. What are they? How do we tell that they are those triangles? Properties of definitions of quadrilaterals. Now, quadrilaterals is a four-sided figure. Now, we can have many four-sided figure. We could have a parallelogram, we could have a rectangle, we could have a square, a rhombus, a trapezium, or a kite. Okay. Congruent triangles, similar triangles, and geometric problems solving applications. Okay, so we're going to classify our quads, our triangles, and we're going to solve problems. Okay. Right, so important reminders, right? So if I'm starting on the top left, okay? So an acute angle is an angle between 0 and 90 degrees, okay? So that's the definition. There's an example there. 49 degrees is an acute angle. A right angle is an angle of 90 degrees, exactly, okay? Then we can have an obtuse angle. An obtuse angle is an angle greater than 90 but less than 180. So the angle there is 126 as an example. A straight line angle or a straight line is 180 degrees. Because remember, if we have a point, all the way around the point is 360. So what we can do is we can draw a line that divides our top half and the bottom half of the circle. So the top half will be 180 degrees. That's going from one end of the line to another. And the bottom line will also be another 180. So that means two straight lines, or top and bottom, will give you a revolution, which is 360 degrees. Right, a reflex angle is an angle greater than 180 but less than 360. Okay, so there's an example of 229. So basically, an obtuse angle will also have a reflex angle on the other side. Okay, if you just look above. All right. A revolution is quite easy. It's a revolution around a point, which is 360 degrees. Acute angled scalene triangle. Now, guys, remember, we can classify our triangles as scalene, isosceles, or equilateral in terms of the sides. Now, scalene means that there's no equal sides in the triangle. All the sides are different. So that's a scalene triangle. Okay. An isosceles triangle is a triangle where two sides are equal, and an equilateral triangle is where three sides are equal. Okay. So those are our main classifications of triangles. Now we can also classify triangles in accordance to the largest angle in a triangle. So remember, sometimes we say there's an obtuse angled triangle or an acute angled triangle or a right angled triangle. Okay, those are further classifications of the triangle, right? So the way it works is that if we look at any triangle, let's say we have a triangle that looks like that, and this is 40 degrees, that's 50 degrees, and no, let's say this is 60, 40, 60, and this is 80 degrees. Okay. So the way it works is that we're going to look at the largest angle in a triangle. The largest angle in a triangle is 80 degrees. That is the angle under which we're going to classify that triangle. So looking at this, because all the angles are different, it means all the sides are different. Okay, so it's a scalene triangle. But what kind of a scalene triangle is this? Well, it's an acute angled scalene triangle. Why is it acute angled? Because the, okay, let me say it 5 times. Because the biggest angle in the triangle is an acute angle. All right, that's how we're going to do it. Now let's say I have a triangle that looks like this. Okay, and that equals to that, and this is 120 degrees. Okay. So what do we have? We have an isosceles triangle because I've told you two of the sides are equal. If two of the sides are equal, the opposite angles are equal. So this angle will be equal to that angle. And if this is 120, it leaves us only 60 degrees amongst these two. So this is 30 degrees and 30 degrees. Okay. But what I'm getting at here is the classification of this triangle. So I know it's an isosceles. What kind of an isosceles? Well, the biggest angle is 120. It's an obtuse angle. So this is an obtuse angled isosceles triangle. Okay. Right, and then the last one is our equilateral triangle. Okay, the equilateral means that all three sides are equal, which means that all three angles are equal. Remember, our total is 180. If we divide by three equal angles, we get that each angle is 60 degrees. Okay, so if we draw an equilateral triangle, we will get 60 degrees in each angle. And we do have that these three sides are the same. Okay. Now, here's the tricky part. Can we have an acute, an obtuse, and a right angle equilateral triangle? The answer is no, because we can only have an acute angled equilateral triangle. Why? Because the angles have been limited to 60 degrees, because that's the definition of equilateral triangle, is that all angles are the same. We only have a total of 180. 180 divided by 3 gives me a 60 degrees. So any equilateral triangle will always have angles of 60 degrees, okay? Which means that it can only be an acute angled equilateral triangle, okay? Right, guys, so that's the next two, or rather, let's continue with the scalene triangle. So we have, right, okay, so let's go back. So I'm going to the fourth line going across. So acute angled scalene triangle, meaning that the biggest angle is an acute angle and all sides or angles are different. Right angle scalene triangle means that we have the biggest angle is 90 degrees, all our sides are different. Obtuse angled scalene triangle has the biggest angle being an obtuse angle and no sides are equal. Acute angled isosceles triangle, okay, remember we drew one just before this one. So that one has two equal sides and the biggest angle is an acute angle. Then we can have a right angled isosceles triangle, which is now 90 degrees. And we can have an obtuse angled isosceles triangle. So two sides are equal and one of the angles is greater than 90 degrees. An equilateral triangle can only be 60-degree triangle, and it is an acute angled triangle. But we're not going to call it that because there's no point because there's nothing else it can be. So we kind of know that it's an acute angled equilateral triangle. Okay. Right angle triangle. So right angle triangle is just, it has a 90-degree angle. And we also have the Pythagoras theorem there. So right angle triangle says that b squared plus c squared equals to a squared, which is the Pythagoras theorem, which we're going to be using quite a lot to solve the questions that we'll face. Okay. Right, guys, so let's now continue with the worked example. It says triangle classification depends on the sizes of the angles and the lengths of the sides. So there's two classifications. You're looking at the sizes of angles and the lengths of sides, okay? What kind? So remember, sizes of angles is talking about acute, obtuse, or right angle, okay? The lengths of sides is now going to be whether it's scalene, isosceles, or equilateral, okay? When the angles are unknown but are given in terms of variables such as x, we can set up and solve equations based on our knowledge of straight lines, vertically opposite angles, exterior angles of triangles, and the angle sum of a triangle. So remember, we've been building up equations and variables and unknowns so that we could use them in order to solve problems. So what they're telling us now is that when they're not giving us angles and they're giving us variables like x's and y's instead of those angles, then what we need to do is we need to set up an equation that links some information that they've given us to the rest of the information with the unknowns, and using that theory that gives us that equation, we can solve the unknown. So an example would be, let's say I give you two angles of a triangle and the third one I call x, and I say find x. Well, the theory states that the three angles added together equals to 360. That's the equation that we are using. Now we're just filling in the info that they've given us, and we're using that equation to solve for the unknown. So the challenge here is to identify what theory I'm going to be using, setting up that equation, telling me the reason for this equation, and then solving the equation. Okay. So let's look at that. Example, so number one, solve for x giving reasons. Okay, so we have a triangle over there, okay? That arrow with the C1, they're just calling that angle C1, okay? So basically, what do we have? We have an exterior angle, which is x plus 50. What do we know about an exterior angle of a triangle? What does it equal? It equals the two opposite interior angles of a triangle, okay? So x plus 50 equals to x plus x minus 30. That is our equation, okay? Right, so let's do exactly that. So we have x plus x minus 30, okay? So x plus, I put this in brackets because there's a negative there, so I need to multiply it in, okay? So x plus that whole angle has to equal to the exterior angle, which is x plus 50. Okay, and the reason for that is, what do they say? Exterior angle. So exterior angle of triangle ABC. Okay. Guys, these reasons, you have to know them. You have to learn them, and you have to be able to tell me what's the reason why you're telling me this. Okay. Once we've got our equation, all we need to do is take x's to the left, numbers to the right, and simplify. So what are we going to have here? It's x plus x minus 30 equals to x plus 50. Okay, now I'm going to take this x to the other side. So it will become a negative. So here I have 2x minus x will just leave me 1x equals to this 30, negative 30 needs to go to the other side. Okay, so that negative 30 will become positive 30. So it's 50 plus 30, which is 80 degrees. So x is actually 80. And now if we look at the diagram, we can fill in that info and it will work. Okay. Right, number 2 says classify with reasons triangle ABC. Okay. Right, let's draw this triangle ABC. So it looks like this. It's quite chilly in this room. Sorry, guys. Right, so we have here, that's the exterior angle, x plus 50. If x is 80, so it's 80 plus 50, which is 130 degrees. Okay, that's the exterior. If that's 130, what's this interior angle here? Well, angles on a straight line gives us 180. So 130 plus what gives me 180? It is 50 degrees. Okay, then this angle here is x, which is 80 degrees. And that angle there is x minus 30. X is 80. 80 minus 30 is going to be 50 degrees. Right, so what can we say about this triangle? So the sizes of the angles are the same here, 50 and 50. If two angles are the same, it must mean two sides are the same, and it's opposite sides. So basically, this side equals to that side, okay? And if we now classify it in terms of acute obtuse, the biggest angle in the triangle is 80 degrees. That is an acute angle. So this triangle is a acute angled isosceles triangle. Okay. What is our reasons for that? Well, we can say that this angle, they call it C1, equals to 50. This angle B equals to 50, therefore it gives us an isosceles triangle. And then you can say this angle 80, which is angle A, equals to 80, which is an acute angle. So there's our justification. Okay. Right, guys, so that is now the worked example. If we go to the next page, we have exercise 11.1. Guys, I want you to work through this, classify these angles, solve for x, and make sure you understand how this works. In the next lesson, we're going to continue with quadrilaterals. We'll run through the different properties, and I'll show you how we solve those types of problems. Cool, guys. Thank you very much. I hope you enjoyed it, and I'll see you next time.